Great, thank you. It's a pleasure to be here. I'm really looking forward to getting some kind of feedback, especially from the demographic side of things. It's essentially the hardest part of working in the ancient Near East is that you never really know how many people you're talking about at any given time, because this is, of course, 4,000 years ago. So there's some wild estimates, and archaeologists usually come up with the wildest ones. And they very rarely are able to be checked against textual sources. And so that's where I come in with this project, is an attempt to try to bring these two worlds together, to bridge a gap between what archaeologists are finding at specific sites that could potentially speak to demographics and in terms of ages and dates and population sizes. If that's reaching, we'll see. But then to pair that with the archaeological assemblages that are still coming out of the ground in these areas as well, and will be an ongoing quest for future archaeologists and hopefully textual specialists as well. Unfortunately, in the past, these two fields have not spoken to each other very much. And so I'm kind of a bit of a mishvazen in that regard, because I started in linguistics, and then I very quickly during my program went to Israel and started getting exposed to the excavations there at the Hebrew University, Tel Beit Shemesh, visited Eshkelon, Beit Sham. And then once I realized that there was this world of big data at the Middle Bronze Age, at least, that my attention kind of went there for the following decade, and I excavated in other places, so Tel Mazan in the Habur, and in Lebanon a little bit, just to try to get the cultural context of where the texts are coming from. All the while I was doing programs in what scholars call Assyriology, which is the study of ancient Assyria, or more specifically cuneiform tablets. So there's so many of them, and they are packed full of data. And there's a lot of dimensions in those data sets. Yeah.
Sorry, I just really am unfamiliar. So you're talking about like stone tablets?
So they're clay, yeah. Clay. So I'll get more into it, but for now it's just a kind of brief overview. What you're looking at in terms of the dots on this map are coming from the tablets. That we get textual attestations of people and places over, at least during this time period in the Middle Bronze Age, for at least 2 centuries here, from 2100 to 1750 is what this data set contains. There are 2 of them that I'm comparing. There are two data sets that are rarely compared, because one of them is in Sumerian, written in ancient Sumerian, this from Pusur-Shtagan, and this is written in Akkadian or Assyrian, Semitic language, and but they're all dealing with trade, the trade that involves people, places, named entities, commodities, and so I'll be kind of going over this. So the demo, if we get to it, which I don't see a lot of computers, so it might not be a super big priority. And it's, we'll see. I'm actually going to be giving a 3-day workshop in the D Lab, March 17th, 19th, and 20th, a 3-part workshop, but you can come to any one of those parts to do either kind of an intro to what network analysis is and how it can be used and useful, some deep dives into data sets that are readily available, and then kind of a consultation day at the end for building your own data sets of networks if you want. So that's all hosted at the D Lab, and you can also find me there under consulting. I'm a consultant for network analysis and computational text analysis. I'm also coordinator for the Digital Humanities Working Group and the Computational Text Analysis Working Group. Computational text analysis. So doing kind of similar things like this, pulling out entities or analyzing kind of discourse in language and thinking about how that's applicable for the humanist, even though it's coming from the social science lab. Okay. So I probably don't need to belabor this point too much because I imagine most of you, thanks to Dennis, know a lot about networks. But I'll just briefly go over. So it's a way of counting essentially people, places, and things, entities as data points in a web of relationships. And I imagine most of you are dealing with kind of, the things that we count tend to be people, but it doesn't have to be. Those things are usually counted on spreadsheets or in databases that could be exported to spreadsheets. That would be considered the node list, the list of nodes that make up a network. What makes network analysis and working with networks so interesting is that you can not just track the nodes as data points and give them attributes and dimensions and metadata. You can actually track the relationships between those nodes. And that's really where it gets powerful, because just like there are many different types of nodes that you can count, people, places, things, and there are a number of different types of relationships that you can count in the same network too, which means that you can model complex systems, multi-dimensional systems, such as the world in 2000 BC. A very complex, multi-dimensional system, and it's not something that lends itself to analysis very easily, because either you're dealing with sparse data, you don't have enough dates, or you have too much of it to count, like all of the homonyms that we encounter on a very frequent basis. So, so those are kind of the important aspects, I think, of networks. They come in all shapes and sizes, and the beauty of getting a network together is that you can then view it in different ways. You can make scatter plots in an XY axis, or you can keep it in just like three-dimensional kind of phases. There are ways of using the relationships that bind the nodes together through weighted models as well. And this becomes very important for archaeology, because archaeologists are interested in likelihood of identifying where unknown places might be based on known places. And I've been working on that a lot lately with these data sets. You can also make ego networks, kind of pinpoint a number of key actors and see the degrees of separation. And this is where usually networks will tell you something that you don't already know, because most of us know one, maybe we can infer the second degree of separation from ourselves in our social network. But what we can't intuit is the third and the fourth and the fifth degree. And so by connecting people and places and things, you can start to get a kind of multimodal understanding of the degrees of separation, and it kind of equates to impact, the impact any actor has at any given time. It can equate to events coming together if you use chronological variables as well. Okay, so networks in a sense are just models, and they're usually wrong, especially for 2000 BC data sets. And so when there's no gold standard, which we don't have working with something this old, we have to find ways of giving numbers and measurements to what amounts to a hunch. We're trying to measure a hunch. We're trying to use inference, and most scholars do that. Historians and philologists do this. It's just that they're not clear about their variables they're using when they make that hunch. And so networks is great because you're very explicit, you get to pinpoint the variables, and you get to use a lot of internal statistics to model society and groups or culture and events taking place. So it's a very interesting for historians, and they're starting to use these tools in history. Discourse and language. This is something that the humanities haven't quite caught on to, aside from what little work like Franco Moretti has done. But just like we can model entities in a web of relationships, we can model all the words that exist on a page or book, or 500,000 books, if we're pulling in Hockey Trust data. So you can see things like ideas being exchanged over time that way. And I'm working on some of that as well. But really what I'm going to be focusing on is modeling relationships and connections between people, places, and things. Very complex world in the past, and I try to pull in as much data as I can. And in fact, that's kind of the prevailing thing that I feel like data is a precious thing and will last longer than the systems themselves. So these networks are kind of fleeting. In fact, I change them every day when I toy with them. So it's not meant to be some permanent model that I say, ta-da, and my work is done and I step away from it. Networks are meant to be interactive and model something over time, but it's really the data that is the really source of real value and treasure in this process. And networks provide a number of ways of measuring your data as well. So you can measure it and analyze it in ways that you couldn't before when it wasn't in the network. So I sound like I'm selling something here. Okay. So funny enough, one of the earliest applications of social network analysis comes from my field, Assyriology, done back in the 60s by two French researchers. One was an anthropologist, the other an Assyriologist. And they reconstructed an economic network with the aid of a very old IBM computer. They basically got together and realized that in order to try to make sense of a collection of tablets, about at the time they were using 4,000 of these tablets that were available from a specific archaeological site called Kultepe, ancient Kanesh. These merchants were moving back and forth between Kanesh, between Turkey and northern Iraq near Mosul. So central Anatolia and northern Iraq, it's about 1,000 kilometers. And so much of making sense of what was happening textually depended on their geographic location. So at the time, there were debates about what it was they were even trading, what commodities were going in which direction and why. And so they used an early sociogram in order to try to disambiguate that problem. And you can see the kind of mind map they were working with here, the diagram that gave them this process. They used one of the earliest kind of clustering coefficients in the process as well. Of course, this was groundbreaking work. So there was an IBM 7090 computer, one of these really big ones that took up the whole room. And they allowed them to analyze a social matrix of 200 by 200 rows and columns. It doesn't sound like a lot to us now, of course. Your spreadsheets, I'm sure, are a lot bigger than that. But at the time, it was a big deal. And it interested early economic historians as well, like Karl Polanyi, who wrote about the Assyrian merchants in his article on ports of trade in early societies. And he was sure to cite Gourlay's discovery about the Cappadocian tablets as the cuneiform mercantile civilization of the millennial age. Well, like fast forward to the millennium we're in now, and we get to kind of contrast what they were up to. And then one of the things that I think makes their work different from the one that I've been working on is they abandoned their project basically due to the fact that even though they could kind of pursue this chain of inference in a structured fashion, they didn't have the detail necessary to pinpoint individuals. So they were kind of amalgamating people. They confronted the problem of homonyms, that in the ancient world, they don't really use last names. And even in some countries in the modern world, they still don't really use last names in the way that the Western world has kind of gone on to do. And so they lacked the specificity in their data set to say something more at the microscopic level. And unless it's microscopic, you'll lose the philologists. So they will say, well, if I can't trace this back to the very text that it came from, then this is not falsifiable, and this is not something that's going to help. Aside from large kind of hand-wavy descriptions of what's taking place. Okay, so they published their work in a couple of articles. He published a book the following year where he really brought the field together in terms of the flow of these commodities as they're going back and forth from Iraq to Turkey. And thanks to this project, they had a better sense of what was happening in the system of trade. But they more or less abandoned it, and it's still over there in France, from what I know, on some big floppy disk that they don't know how to do anything with. Okay, so we can fast forward today and look at different methods that we've been using as the data set's slowly grown to 23,500 tablets today. The site is still active, and they excavated it ever since 1948, moving forward every season. And so, and they have been finding tablets still, so it's not like we're done here. But for my dissertation, the Old Assyrian Social Network, I worked with David Baman and his advisor on leveraging kind of latent signals that were taking place among these data sets. So that initially I realized that they were talking to each other in a hierarchical fashion, very much akin to a parent-child hierarchy. So I wanted to see if I could get a relative rank for those parent-child relationships that were taking place across these texts. And it generated a number of ranks, from anywhere I wanted, from 0 to 1,000, or if I went into that smaller, it would do this using latent weekly allocation, which has a bit of a randomizing element, which means every time you run it, it's slightly different. But you can kind of see where it converges and say, okay, here I can see what these scores are, these scores that they are ranking each other when they write letters, essentially an email exchange between 20 people where every individual is ranked kind of hierarchically. And at that point, it was too complex to kind of keep in my mind, and so I moved it to a network. Yeah.
I'm trying to understand how this ranking, is it just by who sends and who receives, or you pick up language, or
it's reinforced,
whether it's formal or informal address?
Yeah, it's basically to and from. So if the person who is senior status is being written to, then they'll say to this person, to the senior person in the series of people that are listed. So they'll say to Puzar Ashur and Pushuken and Buzazu and Ikun Pasha from Ashur Malik and Shalim Achum and Lulu and Nupuzar. So you'll get these long sequences where they slowly list the most important person first and then their subsequent chain, followed by the letter writer, or now they flip that if the letter writer is the most important, and then they'll start with the letter writer. They'll say from me, if they're the most important person in the row, and then they'll list all of their colleagues, and then they'll say who they're writing to, and then list all of those people who should hear the letter. So, and that it's called an introductory formula or epistolary formula among the philologists. And that has this kind of flexible variability so that this signal could be, kind of interpreted in a way. Turns out they were modeling two things at once. They were modeling the age of individuals, but they were also modeling their proximity to the royal family. So that would always throw off the signal. If who you're writing to is the crown prince, and it doesn't matter if he's younger than you know, he's still going to be first in the communications list. Okay, but in order to tease that out from the data set, it had to go into a network form. And that's one thing that I found networks really useful for. If you're working with language models like topic modeling or doc2vec, word2vec, BERT, deep learning models, then you're probably going to want to visualize that in a network at some point to really understand what's happening at a greater dimension. Okay, so from that initial step of getting these texts into a network, I was able to look at what was happening across a number of generations. And I realized that what was missing by and large were really strong dates. So most of these texts don't have a date. So that we can kind of intuit what's happening based on who's saying what when. Some of them do have dates. Their debt notes and contracts are dated to what's called a royal eponym year. So you have this eponym list, and you have Assyrian kings that are listed as well that we can kind of synchronize at some point. So thanks to the network and like aggregating all of the accounts in the text, I was able to kind of see where along the chronological sequence these actors are most active. And in many cases, their death will be recorded, but of course their birth isn't. We don't get like birth records there. So so it's kind of like a mode of triangulation to try to estimate lifespans and things like this, which of course you have to have if you're ever going to get real demographic analysis. And it is it's a struggle because not every person dies or is told when they die. And also for the wives, when the people who they're married to, we rarely know very much about them. There's only like 350 documents that mention some of these wives and second wives and handmaids and female slaves. But by and large, they rank them, funny enough, because they write letters to them in these 300 documents, so that we can see kind of their social position in the same hierarchy that the Assyrians are ranking. So it makes a really interesting comparison. Either they're usually very young, or they just fall at the bottom of the totem pole because they're not Assyrian merchants. There could be something like that.
Sorry, can I step back?
Yeah.
And ask a question about sort of the data generation here. So where do you find these cuneiform tablets? Are they in like a repository or a library, or are they in these codes? Or?
Yeah, they are. They're everywhere, basically. They're kind of exploded since the initial discoveries. So this, you can see, it's taken from the Ankara Museum. I was over there in the Ancient Civilizations Museum. Or sorry, not museum. The museum. So they have hundreds of thousands of tablets that date to this time period, more or less, and later. There's about 4,000 years of cuneiform documentation. So Ankara, Istanbul, even the Hearst Museum, we have about 950 tablets in our collection here. So they're kind of disseminated widely. They were digitized into databases, and these are open source, more or less, databases. Most, at least the best ones, are open source. There are some kind of scholars keep private collections on FileMaker usually. So
I'm sorry. What I meant was, where do they originate in the archaeological site?
In the site itself.
So I'm getting at sort of the representativeness. Of
I see. Yeah.
I'm sorry.
No, that's great. I can show you on a map where that lives, but basically you have like an archaeological mound usually, and that mound in the case of Kultepe is something like 300 meters. So it's huge. It's a big mound, and the site of where these tablets are coming from didn't actually come from the mound. That's funny enough. It came from a lower level to the northeast, kind of quadrant of this area. And they've since been excavating around, and they've seen that there was kind of like a settlement, a colony here in that corner. There's some great sources I can point you to in terms of like where that is on the map. But there are like large archaeological plans that I can pull up really quick if you want. I didn't include it in slides though.
Is it kind of like they were like in a dump, or were they being kept?
Oh, I see. They were in house. They were found in houses. So these are all private archives. So these are not palace archives, and these aren't administrative archives like I'll talk about in a minute. These are private archives and dossiers. So the thing is, this is kind of like a merchant group of merchants that are coming very early to this site because there is a lot of copper in the area. And so they're bringing tin from Afghanistan, presumably, or Iran, and they are hightailing it over to Turkey on a donkey back with literally tons of this stuff in order to make 100% profit sometime on the exchange between copper to silver. So they bring the silver back home with them, but in exchange for tin. So sorry, not copper, tin. They do a lot of trade with copper as well, copper and wool. A lot of textiles coming from Iraq are being traded up in Turkey as well at the time. Basically, it's like one of the biggest precursors to something like the Silk Road. Although it's not that formalized at this point, it's not a highway. It's a series of stations and inns and villages that these merchants are using as stopping points between a lattice work of, well, I'll get there. We'll see some geographic networks in a second. So of course, there's ego networks, and like I was saying, we can measure the kind of emic rankings that they're making for even the lowliest of individuals. So this is the second wife of this merchant Ashur-nada, and you can see, so 1,000 was the lowest score, and so she's quite young there, or relatively unimportant as far as the Assyrian merchant ranking system goes. The women are always outliers because they're not so active in the documentation. Okay, so then I was able to look at how these individual documents come together in archives as well, and we can see that there's some emergent properties in this case, because the archives of Umm-Ilum and Inaya and Shalim Ashur and another Inaya and Ashur-nada were all kind of organized and curated and put together by scholars into editions and publications. But the nodes in white that are in the middle of this is an archive that hasn't been edited yet, and it's the archive of Pushukin, and he was a prominent merchant involved in a lot of the trade. And so by kind of seeing how things are related, you very often get to see what hasn't been done yet, and what like some really interesting possibilities for editing a new archive there. Okay, so here you can see the geographic kind of layout of how these texts are laid out. I'll come back to that in a second. So you can see on a map right now, this central point here is Kanesh. This is the main colony, and this is Ashur near Mosul in Iraq. So they're traveling from Ashur to Kanesh, and there are a number of paths that they'll kind of stop at along the way, including, some that we're not so sure where they exist. Purush Hatim is still a question mark, but more or less, a lot of these points are fairly certain, and we can see the geographic nodes are in red and the people nodes are in green in this map. And I'm going to just show you kind of some of the benefits of getting it into this. So like I said, the first one is that we are able to look at this along a sequence of chronology. So that each of these individuals are attested in time and in place, with some mention of where they're at a given time, at any given time. So in order for me to see the activity of individuals as they change over time, I'm using what's called an attestation network. Instead of, say, merging all of the nodes that I think are the same person into one, I'm keeping them atomized and linking them. So with this, you can see that there was this collapse of the early colony, and then a slow and steady continuation, actually, of the more local Anatolian population after the Assyrians presumably kind of stopped their documentation, at least. It dies out. Whether they do or not is a question. They probably go back to Ashur, a lot of them, but some of them stay because they have families there in the region. So this gives a great sense of what you get to do if you have some estimates, at least, like minimum, maximum values for when these texts are taking place, and some semblance of a geographical network as well, mentioned textually. So then you can use this to try to understand, you know, the prevalence of certain individuals at certain places. So you can see, for example, you know, who is primarily only staying here? Well, there are a lot of women who are there, who are staying at home, writing to their husbands, you know, far away over here in Kanesh, saying, I'm sending you textiles, can you please send us money? The conditions in Ashur are harsh, the taxes are going up on our houses, and then we have nothing here to eat. Like, you know, you hear things like this, especially closer to the end of the collapse of that first period. And so you get these really personal communications back in the day, along with like very, you know, a large number of basically like 7-Eleven receipts, you know, these kinds of things where it gives you a timestamp of something being exchanged or some debt that's going to start accruing interest after a certain day. And then that allows us to look at the itineraries of individuals as well. So Ashurnada, the husband of Shishak, he is a really kind of important middleman. He's not very high in the trade necessarily, but he gets around, and he has he uses his Anatolian network of influence to get up here into Kunamet. We know he had a house up here. And then we can see by mapping this that he never mentions that he's taking this pass, which is it's called the narrow route or the smuggling route. It's one that was regulated by the king and royal family that was used to very often smugglers would use it for controlled commodities, like very high priced commodities, meteoric iron, for example, that they're collecting and trading at this time. So this gives us a sense of, at least in some way, of where this person is and the preponderance of his activity along the many stations and trade ports that connect the Assyrian city that will eventually become an empire in the Neo-Assyrian period, long before it does so. And in a sense, it gives us a gist of where the money's coming from as well, because they're getting a lot of money from this trade. Okay, so from this dissertation study that I kind of went through, we learned a lot of important things. It's aside from the relational matrix for multidimensional modeling, I was able to kind of get a sense of what you can do when you don't have hierarchy, when you don't have a clear explicit hierarchy model with degree centrality, and to start looking at how counting people over a network can be really telling, even if you're just counting where they're at and when. I also saw that when you do have a hierarchical relationship, such as people and places and things, that using the dimensions and that kind of hierarchy in the network will give you additional kind of narrative points. It'll help you understand hubs and authorities, these kinds of eigenvalues that tell you emergent qualities in the network. I used these lessons learned to, along with how geo-coordinates can be used and time intervals, in a project that I've continued here at Berkeley, which takes in the Sumerian Ur-3 corpus. So there's more than 100,000 of these texts that have come from southern Iraq, from between 2100 and 2000. We're moving back into time about 50 years is all. Most people don't connect these two data sets because, again, they're two different languages. There's a 50-year gap, and if there's a gap, even if you don't know how long that gap is, in antiquity, a dark age is a dark age, you know, and you just assume that nothing existed. It was a black hole between the moments that you have texts. And this is also, these aren't private archives. These are administrative or bureaucratic, and Assyriologists hate when you use these terms, but they're basically like offices that are keeping track of the ins and outs of animal trade, specifically here at Dreham at ancient Khuzrish Dagon. So we took the 15,000 tablets attributed to this site, and we used some machine learning tools to make sure that those 15,000 texts really kind of belong. And we started to measure the same types of variables. We were looking at the roles that certain people play. We can see here, this is a title, a sangha, he's an official, this person. So they're just trading animals, a female lamb and a female kid. It tells us who, so ki, gudea, ta means that it's from that person. So these texts are marking the source of the good. They're also marking who received it, idab, who picked it up, or ba'u, the hand of the god Ba'u. And then it gives us a month and a year, which is great because now every one of these tablets is dated at least to the month, some of them to the day. So that means that we can measure commodities and people and places on a day-to-day basis. We basically have stock market deep data here, Wall Street data at 2000 BC. But because it's so large, because there's so many of these documents, it's been really difficult for scholars to map the ebbs and flows of what's going on here. And so we've aggregated this in using these variables. Of course, one of the main problems is that we're dealing with a lot of people. So here, for example, there are 3,394 instances of Abba Shaga. Now, that's probably one person because he is very prominent in Dreham. Almost everything is going to him. He's the hub of the trade. He's this big white node here in the middle. So we're looking at an aggregation here where it merged all these instances, and we're looking at the instances here. So two networks that are just kind of overlapping for this demonstration. And you can see that Lujingara, for example, we know that there are two Lujingaras. But it's very difficult to know which texts go with which person. We have no gold standard data there. And so we're using the networks to model all of these dimensions and weight them based on consistent parameters so that we can merge the network in many different ways. And we're on our 9th or 10th iteration of these kind of merging processes. And we are working on adding place names as well. So so we can see here, we have the chronology, so we can easily see that during the reign of Shulgi, nothing much is really happening. There's a basic network, but really closer to the end of the kings, and there's 4 or 5 that it goes through, it kind of rises and then collapses. So we get to see a little bit of a bubble, market bubble. And then we can look, whoops, I skipped over. We can also look at this in geospace as well, just like I was demoing with Assyrian. In fact, some of these sites map onto the same Assyrian sites as well that the ancient Assyrians are trading at. Although most of the action is taking place down here in southern Iraq, below Baghdad, basically, below Baghdad. And we can see that, so I was only able to map 50 of the 350 place names, geographic terms that are mentioned. But that's enough for network analysis to give you this kind of ability to use weighted gravity models and see what kind of clusters after you map those fixed points. And you can see there's too many for any one scholar to kind of figure out where they lie. And so by kind of simplifying this process and slowly going through and looking at, okay, that's a canal name, maybe we can place that here in an ancient canal bed, okay, and we can start to look at where these cluster most frequently. It could give us a likelihood score for where some of these unknown sites are. And you can see, like, there's a lot of different algorithms that you can use for these weighted models, depending on if you're using like log scale, log linear regressions, or force directed, just based on the number of occurrences or the number of relationships between any two of these nodes. So lastly, the other thing that these data sets are good for is for comparative purposes. Again, it's really hard to get a sense of how many people we're talking about when we have all these texts with so many homonyms. Fortunately, there are a lot of other modern data sets that are doing the same thing. The Enron email network that comes from 150 people at Enron, but has a lot more accounts linked to it, so that we can get a kind of comparable sense to some degree of how many people we're talking about through their email communications. It's like comparing apples and oranges, but the nice thing, and that's usually a no-no, archaeologically especially, but the nice thing about the network is that you get a lot of precise measurements for when you have relationships between people, and that those can kind of help guide your attempt to try to get a sense of how the scale of things, basically. So that's basically, so again, we're mapping X, Y, and Z. Now this is, I think, really important for archaeology because usually you're working into time by moving down into three-dimensional space. Very rarely do archaeologists actually map the Z. They get the X and Y just fine, but they have to draw out in the Harris matrix or something where the Z is. And I think that this is a big seller for archaeologists because networks will map the Z for you, especially if you already have nodes that have a Z in it. And so you could essentially take, with your grommet or your total station, and get XYZ scores for all of the pottery assemblage from one area. And it sounds crazy because nobody does this. Nobody takes every instance of pottery, but what they do take is every tablet. So philologists are already doing this, and philologists would love to have XYZ data for every tablet that comes from a site. But it's kind of, we're not there yet, but the tool is, and this is, again, open source and ready to go. So I have a number of Gephi data sets on my GitHub. We probably, we have about 10 minutes maybe. Okay, so I can demo some of this if there's an interest here. I know that you probably have seen Gephi before, but I don't know if they've talked so much. Oh, before I do, I'm just gonna do a quick shout out. People and places and things aren't the only thing you can model in networks. So you can also model the results of language models. So if you want to see how texts are speaking to each other, how ideas are being communicated, how the preponderance of cosine similarity scores in Dr. word to Beck. You can unpack what's happening with deep learning algorithms in really intuitive ways, using networks as well. And this is something that I'm developing. I'm kind of testing the boundaries of Gephi, to be honest, which is nice because it's open source. But there's a lot of other tools out there like Neo4j that will lend itself to further exploring. For example, you want to read 1 million books all at once, or you have, let's say, a simpler problem. All of us have a bit of a corpus on our computer that we carry around and that we use to kind of flesh out our bibliographies and things like that. Well, how does the paper that you're currently writing relate to those papers? Well, you have a sense of it intuitively because you're writing it, but you can count the literal connections between what you're writing and what everyone else has written before you just by running it through a language model. And it doesn't have to be structured data because BERT takes in raw texts, and it doesn't have to be in your language even, funny enough. There'll still be commonalities and things that take place across languages even. And so it's at least something to think about. These are providing new ways to kind of unpack how you as a scholar are related to all the other scholars in your field. And I know we're already thinking about this thanks to academia and library catalogs and things, but you don't have to wait until you publish the document to see how that is related and connected. Okay, so here's Gephi. I have it open. You can download Gephi for free. It works on any computer. It's like 0.9, so that means it's beta software. It's not it's not like so basically it can crash on you sometimes if you try to load something too big. But it's really quite useful, and it's pretty stable if you know how to use it well. It's also really intuitive because they built into it this kind of front end here that you can go and investigate these little clusters of people and their relationship to a place here. And you can, like I said, kind of unpack what's going on at any of these places and what's taking place here by investigating any one of these. Let's see.
So can I ask a question about that, what you were just showing?
Yeah, I think I just lost it, but it'll come back hopefully. I'll get there soon.
So what were X and Y in that?
X and Y, that's a great question. So you get X and Y are taking place in geo-coordinates, using geo-coordinates, Mercator in this case.
And what, I mean, then there were some red dots and black dots. Like
Yeah, so there's two modes that I'm measuring here. Places are the red ones, and then the green were the people. And I'm measuring those based off of the degree, like how many connections there are between them, and so you can see, how frequent it's mentioned, for example, among the merchants who are traveling there. But let's see if I can get it back now. That's the thing, like I said, it's still kind of in the beta mode. Yeah, there it is. And okay, so yeah, so the black dots are all of the named entities, all the people basically, but there are mostly people in this network of the old Assyrians. And we can contrast that with the Sumerian network as well, and look at all the people that are kind of active in the trade here, and get a sense as well in terms of, I mean, I don't know if you've ever read an OR3 text, then you know that it's about 6 lines is all, and it's telling you something pretty boring, There's not much there, aside from the date that could be interesting to some people. But it's basically like a 7-Eleven receipt, except that we have like 100,000 of these things within a 50-year period, sure, it's like a century, but really it boils down to like 50 years. 50 years, 100,000 receipts, it starts to get interesting all of a sudden if you can look at it at that scale. And that's what networks provide. And so one of the things that I've found in doing this kind of aggregation work is that these two data sets, believe it or not, could be connected. And that's the thing that I'm working on writing right now. That there are some prominent families in the old Assyrian period who practice what's called toponymy, where they name their child after their grandfather, after their father, basically. And then that persists for generation after generation. You'll see this happening. And it's not every family that does this. It's just some of them in the trade. It seems like the most, prominent ones, the ones that are really active in the trade and closely connected with, or a family to some degree, are practicing this type of naming convention. Well, thanks to that, I was able to find some of these eponymous names in the Sumerian data set. Because there's a few patronymics that they'll use, meaning like Adam, son of Joseph. Like, so you'll get these son and father names. And it's kind of indicating that even though there was a collapse of this Neo-Assyrian, you can see we can enable the timeline here, and that everything kind of withers away, and the network becomes really sparse at the very end of our documentation. You can see here, it gets really dense here, and then again, like at the beginning of the reign of Shul, we have just like a bare bones structure of what's taking place. So again, this slider function is really like just filtering based on a min and max. So we can have min and max years for each one of these nodes, thanks to the dates. All of them are dated. And we can then say, okay, I'm only interested in the people who are here at the very end, because it collapses around 2004 BC. And the Neo-Assyrian, the very first people who were there in Ashur, are about 1930. So there's a little wider than a 50-year gap, but we're not measuring from the moment they're born here. They show up and they're already mid-aged. Okay, so we can come in here and see that one of the more central figures that I was modeling in this thing, if I can find. Okay, so the nice thing about Gephi is that you have this backend as well. So I'm looking at the nodes list here, and I'm still filtered for this specific data set. And you can see there are not many, but I have some patronymics here. Let's see. One of these patronymics is, or at least one that I found so far, is a eponymous name that I can link to the same patronymics here as well. So they also give, well, in this case, their wife or the son of certain individuals. And then you can see, so I have two modes. This is just for people, which is why they don't have geo-coordinates. But because I have some nodes that do have coordinates, and I have connections between when a merchant mentions a place name, I can then kind of cluster them around in space and time in order to see what's happening with events in history in these types of things.
I see your clock go to 1:10 and we're 1:05 here, so maybe we should. Is
Right.
this a good place to pause? Do you want to say one last word?
No, I think this is it. If you're interested in delving into this and getting your hands on the data sets, like I said, they're all open source, and so you can come to the network analysis workshop at the D Lab, and you can play with these among other data sets. There's some Marvel Comics ones, and there's some really cool. Actually, every professor at UC Berkeley has made it into a network from 1980 until 2017, along with all the departments and majors and any graduate student that dissertated from Berkeley. So it's a huge network, like 80,000 nodes. But you can find yourself, I'm sure, you know, and say like, okay, what is my ego network here? You know, that was developed at the social science matrix with Bill Haynes. So if you're morbidly curious about what your ego network looks like as a professor across departments, interdepartmental, how far is your reach across departments, you can do that. And if you have any colleagues who's dissertated and you want to see, you know, where they're at in the network, I'm sure you'll find them too. So, so there's a lot of stuff there, Twitter networks and things, of course, also. But we'll that'll do it. Thank you.
Thank you.